Everything we know about the universe is built on the steady tick of the clock. But there are places in the cosmos where time doesn't just break, it vanishes. The following narration is a simplified exploration of the extreme physics of black holes, based on research from NASA, the ESA, and peer-reviewed studies in general relativity. This is not personal opinion, but a synthesis of scientific data intended for educational purposes. While we strive for absolute precision, any minor inaccuracies in this complex topic are unintended. Imagine watching your greatest enemy fly a rocket ship toward a black hole. You expect to see them accelerate and be crushed into oblivion. But that is not what happens. Instead, as they reach the edge, you watch them slow down, freeze in place, and eventually stop. To you, they will remain there, suspended at the edge of the abyss for the rest of eternity. Why does the universe refuse to let us see anything actually enter a black hole? The first clue lies in the way gravity interacts with light. As your nemesis zooms toward the abyss, gravity becomes unimaginably strong. Normally, you'd expect the ship to speed up as it's pulled in, but from your perspective, the ship appears to be slowing down. This answers a small question. Gravity is so intense that it is physically warping the path of light returning to your eyes. But this creates two much bigger questions. If they are slowing down to a crawl, are they even moving anymore? And if their clock is tied to that light, what is happening to their reality? A strange observation. But then, scientists noticed something even stranger. It's not just the ship that slows down. Your nemesis appears to be shaking their fist at you slower and slower. The deeper they look, the stranger it became. This isn't an optical illusion. It's gravitational time dilation. According to Einstein's general relativity, a theory recently tested with extreme precision by the LIGO-Virgo-Kagan network, gravity doesn't just pull on matter, it pulls on time itself. For you, the observer, their time is literally grinding to a halt. This presents an unexpected and terrifying possibility. At the very instant they should cross the event horizon, the point of no return, they do not disappear. Instead, they seem to stop, frozen in time. The stakes here are reality bending. We have discovered black holes at the centers of almost every galaxy. If this freezing effect is real, it implies that every piece of matter that has ever fallen into a black hole since the beginning of time is still there, still present at the threshold, like a fly in amber. However, the real mystery had only begun. If everything is frozen at the edge, how do black holes ever grow? What we discovered next changed everything. NASA's Webb and Hubble telescopes have confirmed that black holes aren't just static ghosts. They are active, growing monsters that consume entire stars. Evidence from gravitational wave detectors reveals that black holes even collide and merge. That wasn't the most shocking part. If we see them as frozen, yet we know they are merging, it means our perspective of time is fundamentally wrong compared to the reality of the black hole. As you watch your nemesis, the light from their spaceship starts to change. It gets dimmer and redder. This is the ultimate curiosity loop. They aren't just frozen. They are being erased. The gravity is stretching the light waves, a process called redshifting, so far that they eventually lose all detectable energy. The suspense builds because mathematically, they are still there. But physically, they are fading from view. They are becoming a frozen star, a shadow of a moment that occurred billions of years ago, yet is still technically happening right now. The most surprising, scientifically supported explanation is that the event horizon is a wall of infinite time dilation. Because light cannot escape the horizon, the information of your nemesis falling in can never reach you. The universe essentially archives the image of their entry and stretches it across the entire life of the cosmos. They did fall in, and to them, it happened in a heartbeat. But to the rest of the universe, that heartbeat lasts forever. If every star and planet that ever fell into a black hole is still technically frozen at the edge from our perspective, is a black hole actually a hole? Or is it a graveyard where the universe stores the final moments of everything it has ever consumed?